Hi, in this video I'm going to show how we can apply static and dynamic analysis, and in particular to figure out how to execute ransomware called BlackCat. BlackCat seems to be a new ransomware family, ransomware as a service family that replaced DarkSide and Black Meta ransomware. So currently, you can see the screen of virtual machine where I have a sample.exe. So first, to make sure we have a sample of BlackCat, let's check this sample on VirusTotal service. To do that, we can upload the sample, but another way is just to calculate hash, for example, using Total Commander or any other online service. So MD5 would be enough for us. So I can open this text file, copy the hash, and then I need to go to VirusTotal and search by the hash. And as you can see, this is indeed a malicious program. It shows that the original name can be DLL, but we can check if this is a DLL or exe file, just performing basic static analysis. I'm going to show it a bit later. And indeed, we have some verdicts that includes ransom in the name of the sample, and even some had BlackCat. BlackCat is a name of the family. Also, on VirusTotal, we can go to details section, and here it provides first various hashes that we can use to identify the sample. Then there is details regarding creation time, first seen in the wild. So we can see that the sample was created on 18th of November and first submitted in December, supposedly after it was used in one of the attacks. More information about sections, and also it's interesting that here you can see the exact compilation stamp, which is 18th of November. And this file was compiled for Intel 386 CPU. This is the target machine. Then we can see the sections. They're not very useful for us at the moment. And also imports. As you can see, this sample imports some crypto libraries. For example, the following function like bcrypt_gen_random is used from the bcrypt.dll library. And it also has a Windows sockets library imported, supposedly to initiate some network connections. So this is information we can get from details section. Relations, it provides possible connections to other indicators like IP addresses, samples, and domains. Behavior, unfortunately, we don't have much information here. However, we can select different sandboxes, and if we talk about sandboxes, we talk about dynamic analysis. So sandbox is a virtual isolated environment. In this case, this is a public online sandbox where you can upload your sample and get the report about the behavior. Unfortunately, not all samples are going to work in sandboxes, because some have, for example, require command line arguments to be provided to be executed. Other check the virtual environment or debuggers and won't work if you do not set it properly. And also information posted by the members of the community, for example, to the reports, to the articles that explain the payload of the sample. And here, for example, we can see the report published on Analyze in Tether. In Tether is a company that is working on development of online service that helps to identify the similarities between the malware families. They call it code genes that this particular sample can share with other malware families. And yeah, we can use this report, and actually it's already here. And we can see that indeed this specific sample has more than 9,000 so-called code genes. This can be attributed, for example, to functions used in this sample that are unique to BlackCat ransomware family. So now we are sure that this sample is a BlackCat. So next is let's identify if the file type is executable. So here you can see some metadata extracted from p header, and it tells that this is Win32 executable file. However, if we don't have this report, still we can use some offline tools to check, for example, pview. Pview shows information about p header and structure of the file. So it starts from legacy image.header, which has this magic byte mz and ms.stub. This program cannot be run in DOS mode that every executable file like DLL executable or sys file has for Windows. Then we have anti-headers, which starts with PE. This is a modern header, which includes a lot of interesting information. For example, the type of the executable file. In our case, this is a exe file. And it was compiled for 32-bit platform. And also time date stamp. So supposedly file header is the most useful for us as a malware analyst. And this provides information about the compilation when this program was created, and if we can execute as an exe file. So now we're sure that this is an exe file, and this belongs to BlackCat ransomware family. Then we can try executing this sample, for example, but first let's start process monitor. Process monitor will help us to track all the changes in the system, but first we need to set up the filter. We're going to use process name. This part is related to dynamic analysis. And the process name will be sample.exe, which means we will see only the events related to the process with the name sample.exe. And then we can start this sample. Let's open the command line. Go to desktop. And here we have sample.exe. So we started sample.exe, and what we can see in the process monitor, we can see that actually it doesn't perform any encryption of any files. So if we remove, for example, registry monitor to see only file events, so we will finally find that process has been exited. The threads, the two threads, and the process has been exited. So for some reason it doesn't work. So we need to figure out what information, how to run the sample, and what information we need to provide to the sample. For example, maybe command line arguments. Also, it can be useful to check if this sample has been already analyzed on some sandboxes. So we have, we know the MD5 hash of the sample, And we can go to, for example, app any run service. This is a public online sandbox where we can submit new samples or search by hash. So let's check if this sample is available. And indeed, we have like 5 analyses performed before. And as you can see, that some analysis didn't expose any malicious actions. So let's wait for the report provided by app any run. So here we can see that the file was executed without any command line arguments, and the only action it performed is checking support languages. We don't see any ransomware related activity. However, we have 3 more analyses that expose some suspicious activity. Let's take a look at this analysis and try to figure out what's the difference between those 2 reports. And here we have, as you can see, it starts several cmd.exe files. For example, one of the executions is about deleting shadow copies. You can see it starts vss admin and provides delete shadows all quite parameters to delete all shadow copies or all disks on the target machine. But what's interesting is how this sample is executed. And if we open, so even here we can see that 2 command line arguments like -a and x have been provided, and as a result we have suspicious activity related to renaming the files. So this is a typical behavior when after encryption the ransomware adds new extension that is used later by decryptor to identify the files that have been encrypted before by this specific version of the ransomware. So after that review, we right now know that we need to provide command line arguments. In addition, we can perform a bit more advanced analysis, and to do that we can use either Pro or freeware and check, for example, imports to identify the potential payload that can be implemented, that is implemented by this specific ransomware. We don't even need to run the debugger. We just need to review import address table and, for example, strings. We can also can go through the code to identify what kind of strings and where are used in this ransomware. So let's go to imports first and try to check if the ransomware uses command line arguments. And we can see that there is a function called get command line. W means it works with white char arguments. And so we can try to find where this get command line is used. And here, after like a short analysis, either provide cross-reference. Cross-reference, this is the place where this function is executed. And we can jump to this location. So we can set breakpoint here. or directly go to the piece of code where this get command line is executed. This will be used for debugging if you want to start debugging. However, it's not necessary, and we can just view the code if there is any comparison with hard-coded command line arguments that this ransomware receives and parse. So we can see that it checks for spaces, for quotes. This is used to split the path and arguments that is submitted to this application. Then we can go down, and we can see more signs here that is used to identify slashes, backslashes, to split the command line. We can also use the graph view, but currently it's not available. But if we, for example, start the debugger, we will be able to use this. So let's continue sliding down. By the way, BlackCat is written in Rust. This is a low-level cross-platform language that is now used by criminals to create different versions of ransomware for both Linux and Windows platforms. So we couldn't find at first glance any arguments. So let's execute this ransomware and see where the get command line is executed. So we set breakpoint before on a get command line. So here we are. And so if I try to switch to graph view, yeah, it works now. And so the get command line just returns the path with arguments. However, we need to go out of this function to find the place where these arguments will be processed. Actually, this is the function that is used to split the arguments, because we can find these spaces and quotes, slashes, the ones that we saw just when we were sliding the program. For example, here. So let's run the debugger until return from this function. And yeah, we need to remove this. Function. Then we return one more time and one more. So currently our program is running, just we need to wait until it completes all the operations, and is going to return from this particular function, where we suppose that the command line arguments are parsed and then will be compared with some keys that will represent options available in the program. Okay, we are out of the function. And so let's have a look if we have something here. So we have this string, but this doesn't seem to be a key. And then go down. So, and finally, we can see that there is dash another dash, and then we have checking for characters H, E, L, P, which if we gather together these characters, it will be help dash minus minus help. And we have alternative branch, which has also this dash and single H. So this is a typical help option that is available in most command line applications. And let's check if it works in our case. So let's get back to our command line and provide, so we can use just dash H. And indeed we have the help. So usually when malware is released, all these like debugging options or command line arguments are removed, so it's not possible to see. But in this case, the developers, they still decided to leave the information about the options. And what we can see here, that we have a help and a bunch of other flags that we can use to enable different options. And let's try to use this information and the information that we saw from the app any run, where we have minus AX. Just more information here, and as you can see, this activates the ransomware payload, which is about encrypting the files and renaming them. So we need to use also this minus AX, and let's check what minus A means. Minus A stands for access token, and then the token should be provided. Okay, let's do the same. Let's use minus A and X as some imaginary token. Then we have a bunch of other options that we could play with. For example, I don't want to let this ransomware encrypt my network shares, because I use this network shared folder to exchange my files with the host machine. So I'm going to use minus N. Then I want to enable verbose option to see all this information, all the debug information that will help me to understand how it works. Then we have a log file, so we can use log file to save all the output to the log. And path. So if I don't want that this ransomware encrypts all my folders and all my files, this will take quite a lot of time. And the second is this may affect my, for example, debugging files, the files under debugger, and some debug information that is stored currently. So I don't want to this ransomware encrypt all my files. That's why I can specify minus P or minus minus path and provide some folder. Let's say we have this application exainfo P. By the way, this is one of possible tools that you can use for static analysis. It provides information about P files. P stands for portable executable. And I can use this folder as a target for BlackCat ransomware. Unfortunately, this option U or UI doesn't work for this particular sample, but still it's nice that we have the rest of the options active. So let's probably terminate the debugger. So we'll have more resources on virtual machine. And start ransomware. So we can see that the log file is written here. And the ransomware creates cmd.exe files. And finally, we can see the information about ransomware activity. It kills the processes, for example, mapox, memtas, VM. This is a backup solution, for example, SQL, VSS. So if those processes, the processes with these names are found, or services, they will be stopped, or if this is a process, then it will be terminated. Then it traverses my target folder, exe-info.pe, and tries to access these files. Supposedly, I've seen other versions of BlackCat ransomware, and they have also additional features as a privilege escalation. So supposedly, before starting this ransomware, they get admin token and start this ransomware with administrative privileges. So finally, it drops ransom note, txt and pg file, and you can see at the background the wallpaper has been populated and filled the whole screen. And at the end, it deletes shadow copies. So the same activity is available in process monitor. So for example, seek FFLE, this is the extension added by the ransomware. And if we open the folder and try to refresh it, and we'll see that now, for example, text files, configuration files, and of course, ransomware encrypts the files with specific extension, and this the list of extensions and the list of processes for termination and services are written in a configuration file. If we are going to, if we start debugging, so we will find this configuration file will be decrypted, and we will get access to that to see the configuration for this particular sample. So all files in our target folder have been encrypted. Then we have a log file also that supposedly, yeah, it's collected all the messages that we saw in the command line. Also, we can see the ransom note. As you can see, the criminal, they supposed to visit the website in Tor network to get further instructions on what to do and how what amount of money they should to pay and how they can get the decryptor. So this is a typical behavior of creators, of ransomware creators. And finally, yeah, this is a picture that was shown at the background. So that's it. So the purpose of this video is to show how we can use static analysis and dynamic analysis tools to understand how to execute a ransomware, because as I mentioned, in most cases we have a problem executing the payload, because in some cases malware requires command line arguments to be provided, or they check virtual environment, they can check debugger, and if we don't see any activity in the process monitor, it means that we need to go through the code or try to figure out what type of the file, if we can execute it, or we need to, for example, if it's DLL, we need to use run DLL32.exe host process to start the DLL, and of course check if the application uses command line arguments, and in such case we need to provide some dummy arguments to this application. So that's all. Thank you for attention.